Today we are going to discuss the topic which is called as structural and non-structural mitigation of disaster. So basically, as the name suggests, structural means related to structure, and non-structural means it is not related to structure. So basically, other aspect other than structural aspect that are included in non-structural part. So before going to the structural and non-structural mitigation for disaster, we should know what is disaster mitigation. So as you know, the disaster management cycle, this disaster mitigation is one of the most important element which is included in disaster management cycle, which is essential for capacity building. So if you have to define this disaster mitigation, it is a type of long term. So this is long term that you have to understand. So throughout the year you have to focus on that. So it's a type of long term pre-disaster planning which involves sustained expenditure on structural and non-structural effort. So continuously you have to go on giving some funds for that, so that you can improve your structure as well as you can improve your non-structural efforts to reduce or eliminate the future risk through proactive measures. So you should be proactive. So proactive measures taken before an emergency or disaster occurs. So basically you can say that this disaster mitigation is a very important element of your disaster management cycle. So throughout the year you have to carry out, and two major focus area on which you have to focus, that is structural part, कि जो भी आपके structure है वो properly disaster proof हो, और second is non structural part, means all the awareness and training and knowledge management and formation of building to look after all this, then proper building bylaws that is to be followed, then proper land use planning that is to be done. So all are included in non structural part. So continuously when such activities are done, and just that will reduce the risk of disaster. So these proactive measures that are generally taken before and throughout the year, that is called as disaster mitigation. So basically in the concept and strategy of disaster mitigation, they are the best and cost effective methods dealing with the disaster over a long term, because it will be beneficial to any country or any state or any city on long term basis. It's not a short term gain कि भाई चलो disaster हुआ तो हमने उसको टैकल कर लिया, हमने लोगों को relief and recovery करवा दिया. So that is okay. But if you are investing in such activities, then it is your long term measures, okay, and that will reduce the risk of disaster basically. So this disaster mitigation involves the combination of strategies, and these strategies involve two major mitigations part or strategies or elements, you can say. First is structural mitigation. So basically, as the name suggests, structural mitigation means it consists of some physical or structural arrangement, such as your essential infrastructure, landscape, and environment. So you have to create such a structure which is basically disaster proof. So generally, more focus is to be applied in the area in which if you are living, that is a disaster prone region, either for earthquake or for flood or for cyclone. So such kind of structural mitigations are to be applied to those structures which are there in that disaster prone region. So structural mitigation related to structural part, and second is non structural mitigation. So as the name suggests, non-structural means structure से उसका कुछ लेना देना नहीं है. It does not include any physical or structural arrangement, but it is related to some policies aspect or so many other aspects that we will learn in detail as we go through. So basically, when we are talking about structural mitigation, so it involves the physical construction to reduce or avoid possible impacts of hazard. So your physical construction of your particular structure, it should such that it should eliminate the impact of any hazard, and particularly important when it is there in a disaster prone region. So basically what you have to do, it's the application of engineering techniques to achieve the hazard resistance and resilience in the structures or system. So your structure should be hazard resistant, and if certain thing happens, that it should be resilience at the same time. Means after disaster takes place, it can be easily recovered, okay, with a small effort. That is the means of resilience. Okay, recovery jaldi aa jaye, okay. And these are the engineering measures and construction. So basically, the civil engineers, they are generally involved in construction part. Okay, so these engineering measures in construction of hazard resistant प्रोटेक्टिव स्ट्रक्चर्स एंड इंफ्रास्ट्रक्चर. सो जो भी आपका इंफ्रास्ट्रक्चर है, जो भी आपका घर है, बिल्डिंग है, ऑल द स्ट्रक्चर, so they should be prepared properly by applying all the engineering applications and techniques to make it disaster proof, you can say. So these structural measures, it include, so these are all you can apply as a structural measure part. So first is earthquake resistant structure. So this is very essential part. Okay, and this has to be followed, because and generally when it is a disaster prone region, particularly for from earthquake point of view, then it should be properly followed by that particular authority. Next is dam, construction of dam, then embankment, then regulator, drain, bypass channel, flood levees. These are all measures which can be applied for flood mitigation. So whenever this flood is coming, so lots of every year you can see that this is very common disaster which is observed every year in India and all across the world also. So this construction of dam, embankment, then regulators, they will regulate the flow. Then drains. So these drains are very important, because generally it is observed that in city areas, if your storm water drain that are not properly cleaned before monsoon season, then that will be responsible for the flooding. So basically, all these measures, they are to be applied properly. Flood levees that are also useful for avoiding the flood. Then ocean wave barriers. So these are important for the coastal region, nearby coastal region, whenever there are chances of the tsunami and that cyclone, etc. So that will take care of that coastal region when some construction barriers are created all along the sea. Okay, then evacuation shelters that are needed for the recovery part. So these are the measures that are related to construction aspect. That's why it is called as structural measures or structural mitigation part. But when we are talking about non-structural mitigation, so this non-structural mitigation, it does not involve any physical construction. यहाँ पे कोई construction नहीं करना. But here, so many other aspects are involved, that are use of policy. You have to prepare such a policy that in disaster-prone region, whatever legal framework related to construction, that is to be followed. Okay, all our disaster management policies, that should be proper. Our disaster management plan, it should be proper, so at the time of disaster we can tackle it in an efficient manner. Next is related to generating awareness about the risk among the community. So all the communities which are living nearby that disaster prone region, they should be aware about whatever risk that they are having regarding particular disaster, so that they can prepare themselves well, and they can handle or they can respond at the time of disaster very well. Okay, and whatever the communication which is done by authorities, that can be well understood by them, and they can have a good response, and that may result in less casualties and less destruction if they are aware. Then knowledge development. So this is also very important. Some knowledge impartment is to be done. Then education and training is to be given. Then public commitment and methods are to be applied to go for this public commitment, that can be enhanced. Then operating practices, whatever operating practices you are having, then all the information system that are to be strengthened. Okay, either it's a communication system or either it may be early warning system, so there should be proper. Then land use planning, so how to use land. Okay, so already this land use planning in detail we have discussed. Okay, so all these land use planning laws and their enforcement, that is to be done properly. Then all the building codes that are to be followed properly. So all the disaster prone region, all the building codes related, whatever provisions are given, that is to be strictly followed, and adherence to these rules and bylaws. So whatever laws are there, whatever rules are there, that is to be properly followed, and that authority has the responsibility to make all the people or all the contractors to follow that particular rules. And the last one is strengthening the capacities of institutional framework. If you are not having proper institute to have the proper following of all the rules and regulation, there is no meaning. So proper coordination between all the institutes which are working in the field of disaster mitigation, and also during this disaster, before disaster, during disaster, after disaster. So this strengthening the capacity of institutional framework, whatever we are having, that is also important part of non-structural mitigation. So in general, you can say that all other measures other than physical construction that are included in non-structural mitigation. So this is the basic difference between structural mitigation and non-structural mitigation. So now we will just see this structural mitigation part in detail, and whatever this provisions that are given, that are from the NDMA guideline only that I am taking. So these are the types of structure which are considered for structural mitigation. So basically, it is given that for the structural mitigation, there are two types of structures that are to be considered. Okay, जो भी structural mitigation means that disaster प्रूफ करना है तो कौन से बिल्डिंग को कंसिडर करना है, ठीक है. सो बेसिकली इन दिस देयर आर two types of structure that are specified. So first structure that is called as building. So these buildings are the major part, you can say. So buildings constitute about 90% of the number of structure. जितने भी structure है उसमें से mostly 90% तो building ही होता है, ठीक है ना. So this building can be subdivided. So there are subdivision is also given so that we can group them in a different types of building. Okay, so that proper structural mitigation or proper structural arrangement or structural part that can be properly applied. So for that there are three groups that are generally given, and that is based on function of use. क्या उसका function है, किस use के लिए building use हो रही है, that is the first part. Second is material of construction, which kind of material you are using for the construction of building. And third is total height above ground, because the measures that are to be applied that would be different for different types of structures. Okay, so for that this different types of buildings that are having given the categories, and these categories as you know, that is first is based on the function of use. So normally very important building that is called as the residential building. So most of the building, because most of the people they are residing in residential building, so this is the very very much important for this disaster. It should be disaster proof, so that residential building in which people are living. So the next is non-residential. So these are all other buildings other than which are used for residential purpose. And third is the critical lifeline building. So these buildings are very important, all the lifeline buildings जिसके बगैर हम रह नहीं सकते. Okay, so this lifeline buildings, so these are to be make disaster proof. So that is important thing: residential, non-residential, and critical lifeline building. Now based on material of construction, basically this is related to civil engineering part, the types of building based on material. So most of the building, they are reinforced cement concrete, that is RCC. Reinforced cement concrete means it's a mixture of that reinforcement bar sadiya jane kevae, along with the concrete, that is a mixture of cement, sand, and aggregate. So most of the building that are generally employing, that is RCC structure. Then steel structure, masonry structure. Masonry is nothing but it is with the basic building material like brick and stone, along with the mortar. Mortar is nothing but it's a mixture of cement and sand. Okay, so that is masonry and other materials that are used. So most of the buildings that are RCC or steel or masonry. Then based on height of building above ground level. So basically these buildings that are also having certain specific requirement. Okay, so height wise also the buildings are classified. So less than 10-meter tall, then between less than 15-meter tall, then between 15 to 45-meter tall, and taller than 45-meter. So for all this different aspects are to be followed. And most masonry building जिससे हम normally हम brick and stone से बनाते हैं, that buildings are generally less than 15-meter height. So in the NDMA guidelines, so these are all that classification etc. that are given in NDMA. Okay, so in the NDMA guideline, all buildings are considered irrespective of whether they are built by owners for self occupations or by builders for the sale. So this laws or whatever that building codes that are prepared, that are कॉमन फॉर ऑल. इट्स नॉट लाइक कि आपने अगर बनाया स्ट्रक्चर तो आप पे लागू नहीं होगा, बिल्डर्स पे होगा. सो दैट इज फॉर ऑल द buildings. Now next component that is included, that is called as non-buildings. So it includes all other structures including industrial structure. So here this industrial structure is considered as a non-building structure. So that is the special industrial area in which we have to apply the particular measures. Next is civic amenities. So all the amenities which are provided by the corporation, water supply pipeline, etc. So that is called civic amenities. Then infrastructure projects. So here in infrastructure project, all the bridges and water supply pipeline and drainage pipeline and so many infrastructures that can be used. Okay, so these are all because they should be also secured against the different disaster, because if some communication gap is there, some building cables that are collapsed, then these are all very important things that are to be disaster proof. Otherwise the whole communication gap would be there. आपका ट्रांसपोर्टेशन लिंक टूट जाएगा, then communication link टूट जाएगा. So these are also very important. So these are also to be properly secured against the disaster. So the infrastructure projects are required to be developed using technical and professional inputs along with the understanding of social, technical, financial and sustainability aspect of the project. So the financial outlay for any construction, it can be from any of the three funding mode. जो भी नॉर्मली हमारे यहाँ पे जो इंफ्रास्ट्रक्चर बनता है, ब्रिजेस या वाटर सप्लाई के रिलेटेड वॉट एवर, दैट आर हैविंग थ्री बेसिक फंडिंग आउटले. फर्स्ट इज गवर्नमेंट सोर्स, सो गवर्नमेंट जो बनाते हैं. नेक्स्ट इज पब्लिक प्राइवेट पार्टनरशिप, दैट इज कॉल्ड एज PPP. एंड थर्ड इज फ्रॉम द प्राइवेट सोर्सेज. So while this provision exists in the government funded infrastructure project, to ensure the development of hazard resistant construction, जो भी government funded infrastructure project होता है, so they ensure that the development should be hazard resistant construction. And also this system need to be put in place to ensure the same in the PPP as well as privately funded infrastructure projects also. So they are also applying all the rules and regulations which are related to hazard resistant construction, which is applied to government funded infrastructure. Similar has to be applied to PPP and privately funded infrastructure projects also. And also where the banking sector provides the lending support, including construction in the special economic zone, which is called as the SAZE, and the large entertainment park outside the municipal limit. So everywhere, whatever rules and regulations related to disaster-proof construction, it is to be applied, because these are also very important part. And whenever disaster takes place, if some failure of such infrastructure is taking place, then the whole communication and that transportation link, that will be collapsed, and it will become very difficult to provide the relief at the time of disaster. So here, after knowing this, which are the sectors of infrastructure projects that are to be taken care as far as the disaster proof constructions are concerned. So all the infrastructure projects that are included in that. So first is that is related to water. So related to water, all the dams, irrigation structure and water transport, to be pipelines and water transportation key, that are to be disaster proof. Because agar just imagine if some destruction of dam that would take place, so how it can result itself in a disaster. Okay, so this are the all structure which are related to water, irrigation structure, irrigation canal, then all the pipelines carrying water that are to be constructed, which are to be disaster proof. Next is power line, all the power supply line that is related to thermal power, hydropower, wind power and solar power. These are all included. It should be hazard resistant. Next is communications, all the communication link, wired and wireless communication, If these are not properly secured, they themselves are hazard. Okay, if any gas pipeline is there, or if is there any some electric cable line is there, if they are not properly secured and properly not laid, then they themselves may become disaster. Okay, next is transportation link. So this is a railway line. So this railways, it includes the trans-country railway system as well as metro rail system. All should be properly hazard proof. Then roadways. So all the roadways, including bridges, flyover, pavement, passenger terminal, highway, and highway convenience and vehicle emergency facilities, all are to be disaster proof. Next is airways. So in airways also, all the airport terminals, runways, taxiways, towers, and fuel tank, all are to be properly secured against the particular disaster. All the waterways. So these waterways, including port and harbor structure, जितना भी port and harbor का structure है, passenger and cargo terminal है, lighthouse है. So these are all the infrastructure projects that are very important uh, infrastructures, and that are to be provided with the proper structural arrangement so that it should be a disaster proof structure. Next is urban services. So basically these are civic amenities, you can say. Okay, so these urban services including the infrastructure and amenities. So all the amenities generally provided by corporation, or you can say by the municipal authorities. So like that is water supply. So water supply pipeline जो आपके घर पे पानी लेके आती है, that if some crack is there, then you can understand the whole water supply that will be disturbed. Okay, then piped cooking gas supply. So this is also very important because it is dealing with gas. Okay, so if some gas leakage will be there, so itself all these urban utilities and services that if they are not properly managed, if they are not disaster proof, and in certain disaster if they are damaged, so they can aggravate the situation of that disaster. Okay, and sewage treatment. So whatever wastewater which is coming out from your house, that is going through the sewage pipeline, and that will reach to sewage treatment plant, and some treatment will be given to them. So they should be also properly secured. Otherwise the treatment would be hamper. अगर बहुत ज़्यादा flooding हो गया है आपके particular city में, so some backflow of that particular sewage, that would also start, that will come up from your toilet blocks and bathrooms, etc. So and so proper treatment that would not be possible in such condition because of the excessive flow of that sewage. Then industrial wastewater treatment and drainage, then stormwater drainage. So this stormwater drainage pipeline or that arrangement, this is very important because during most of the time, whatever that flood, etc., that we are observing in city areas, that is due to either uh, not properly prepared or installed this stormwater drainage, or either not properly managed and maintained stormwater drain. प्रॉपर सफाई नहीं करते हैं, उसकी वजह से फ्लड हो जाता है. सो मोस्ट ऑफ द टाइम इन द सिटी एरियाज वी कैन सी दैट naturally whatever rain is coming during your rainy season, it is less responsible for the flooding than the it will become man-made. Because why? Because first thing, if we are having dam and we are not regulating the flow properly, in that case we have to allow the flow to go to the other natural stream which is passing by your area. Okay, and that will increase the level. So it may be considered as a man-made flood only. And also if the stormwater drainage pipeline, they are not properly maintained, and due to that excessive flow that cannot be taken by them, so ultimately it will also increase the condition of flooding. So basically it is observed in most of the cities that this flooding condition which we are observing, or which we are facing every year in the monsoon season, it is more like man-made than the natural. Okay, so this proper arrangement of this stormwater drainage is also very important. Then solid waste treatment and its disposal. So these are all the public utilities and amenities which are to be properly secured against all the disaster as well as properly maintained. So in the infrastructure projects, they are again subdivided into two parts. First is discrete development, and second is linear development. based on their geometric spread on ground. कितना ग्राउंड पे वो स्प्रेड हुआ है इसके हिसाब से उसका दो पार्ट में डिवाइड किया गया है. फर्स्ट इज डिस्क्रीट एंड सेकेंड इज linear. So here you can refer this overhead tank. So most of you have found that in most of the areas we are having this overhead tank. Okay, so that is basically the main distribution system in which the water will come up from your overhead tank, pani tanki. Remember? So basically it's a discrete development. So it include the individual standalone construction. कोई अकेला एक स्टैंड अलोन कंस्ट्रक्शन है विथ रिलेटिवली स्मॉल फुटप्रिंट, जिसका मतलब फुटप्रिंट बहुत कम है, मतलब जगह जमीन पे कम गिरता है, एंड इट्स अ स्टैंड अलोन. ओके, इट्स अ स्टैंड अलोन काइंड ऑफ डेवलपमेंट. सो बेसिकली दिस वाटर टैंक फॉर द म्यूनिसिपल वाटर सप्लाई और कूलिंग टावर इनसाइड अ पावर प्लांट एरिया. So these are considered to be a discrete developments. So they are also should be disaster proofs. अगर suppose earthquake यहाँ पे आता है, ठीक है, and as you know that the height of this water tank it may be 20 to 30 meter. So if these columns and beams that are not prepared earthquake resistant, then what will happen? Okay, so that may collapse. So all these structures that are to be prepared and hazardous proof, or it should be disaster proof, you can say. Next is linear development. So basically linear means in line. Okay, so it includes the long span or long length facilities spreading over larger distance and crossing the different terrain which are vulnerable to different natural hazard. So just pipeline. Okay, so here the length would be more and it may pass through different areas. Okay, so this trans country pipeline. So normally एक country से दूसरे country में जब हम petrol, diesel etc. that we are taking, so this trans country pipeline for the petroleum fuel crossing the earthquake fault zones. So if they are not properly secured against that earthquake hazard, then definitely that will create more problem whenever earthquake takes place. So it may be said that one disaster is there, but that may result in secondary disaster. कि भाई चलो एक पाइपलाइन वो पूरा आपका डैमेज हो गया तो उसकी वजह से गैस लीकेज हो गया. सो one hazard is already there, it has resulted in disaster, and similarly if it is not disaster proof, then it will also result in secondary disaster. Okay, so it will aggravate the situation of disaster and it will become very difficult to handle such kind of disasters. So large diameter water lines which are laid on different soil terrains, national highways, subsurface tunnel and long span bridges. So these are all passing and these are all crossing so much area, means that area that it is in one line, you can say. So so different areas, different soil terrain, different fault zone as far as the earthquake is concerned, they are passing through that. So they should be properly secured against the disaster, otherwise they may result in secondary disaster. So which are the natural hazards to be considered? So this national standards and guideline consider the potential impact of each individual hazard. आपको ऐसा नहीं कि भाई एक ही hazard को consider करना है. You have to consider the impact of each individual hazard. You have to find out that if this is the area in which you are having certain civic amenities or any infrastructure project, then you have to separately consider for each and every individual hazard which are possible. So the safety of the built environment, it needs to be assured to withstand the adverse impact of multiple hazard. Okay, whether it is safe against earthquake, whether it is safe against cyclone, whether it is safe against landslide, whether it is safe against flood. And once you are doing this risk and vulnerability profile of specific area, you come to know that these are the risk factor and these are the vulnerability profile. So that's why that whatever that HRV mapping that we are calling it, hazard risk and vulnerability analysis, that are very important before this construction of all these necessary infrastructure project. Some design features favors to resist the effects of one hazard may conflict with the features required for another hazard. So here I will give you a very simple example. If your particular region or city or your particular area, if it is prone to earthquake as well as flood, okay, So if you want to consider that कि earthquake proof resistant बना earthquake resistant structure is to be there. So in that case you will like to reduce the height कि भाई tall structure नहीं होना चाहिए, थोड़ा नीचे रहे तो अच्छा है, ठीक है. But if some flood condition, because it is also prone to flood, so in that case if your plinth height जो भी आपका floor height है, if it is at not proper height, then always there are chances that you are suffering from that flood every year. So in that case you would like कि भाई आप थोड़ा tall structure में रहते हो. So this kind of design features that one is favoring to one resistant कि one hazard के against वो resist करेगा, but it may conflict with the features required for another hazard. So that is also possible. So implications of these needs to be incorporated before arriving at the final design. So whatever that final design that you are doing, you have to consider both the aspects. It should be earthquake proof as well as it should be flood proof. So based on that implications that are needed, based on that you have to arrive at final design, and you have to go for such kind of construction of your structure so that it can resist all the possible uh, hazards that are prevailing in your area. Okay, so experience of the performance of the built environment with certain design features, it helps in resolving such kind of conflicts, because that hilly regions they are also having multiple hazard. वहाँ पे earthquake भी आ सकता है, वहाँ पे flood भी आ सकता है, वहाँ पे landslide भी हो सकती है. So those structures which are suffering for this multiple hazard, the proper design is very essential. Otherwise it may result in first hazard to first disaster as well as second uh, disaster, that is secondary disaster. So safety items considered. So the demands of all the natural hazards are of force type loading कि भाई लोड कैरी करना है, that is called as the force type of loading. While earthquake hazards, earthquake जहाँ पे आता है वहाँ पे displacement type of loading होता है कि भाई lateral movement होता है आपका. So most of the hazard then the construction that we are considering, that is force type loading के लिए हम consider करते हैं. But when we are designing for the earthquake type, तो displacement type of loading consider करना है because that lateral movement would be there. So this lateral action is a dominant feature of the hazard, especially under wind, wave, and earthquake. In addition to usually gravity load. So most of the structures that we are designing, वो gravity load हम consider करते हैं कि भाई कितना gravity से load आ रहा है. But this lateral action is very essential when we are designing for the wind, wave, and earthquake resistant. So in the design structure, the four virtues are to be properly followed. First is configuration. क्या configuration है, कितना stiffness है, कितना strength है, and ductility. So basically this ductility, this first three virtues जो मैंने बोले, configuration, stiffness, and strength, which are very essential for resisting the gravity type of loading, means to resist the force type loading. But when we are considering the displacement type of loading, means earthquake resistant structure बनाना है, so this ductility aspect is very important. So you have to combine all the aspect when we are considering with the different types of hazard. So basically this safety, it should be applied to both structural system as well as non-structural system. So basically in the structure, it consists of two part. अभी structure में भी दो part होते हैं, ठीक है. So one which is called as structural system and second which is called as the non-structural system. So these non-structural systems that are called as contents and finish. So basically in your structure, the structural system means क्या है? A part of the construction which is responsible to carry the loads acting on the structure. So there are many types of loads that may act on your structure. So its own weight due to occupants, then contents and finishes which are there. So basically this structural system, it consists of all these load bearing structures like foundation, column, braces and beams, and the slabs and walls that permit the various activities and function to be undertaken within the structure. So basically load लेने का काम कौन करेगा? Foundation, column, braces and beams, and the slab and wall that will just transfer their load. Okay, so whatever that structural system that we have designed, it should be effectively in taking the loads, okay, without any threat of collapse an unexpected natural hazard and normal loads appearing on the structure. So it should be capable of taking whatever loads that they are having. So all these members of structural system performing this function, it is called as structural elements. So आपका जो structural elements है, so here basically in structural elements in our civil engineering we are having two types of structure. एक तो होता है load bearing structure and एक होता है frame structure. So basically in the load bearing structure, these walls that are responsible for taking load, जितना भी load ऊपर से आ रहा है, that will be taken by this wall and that will be transferred to the foundation. So below this we are having again foundation. Okay, so that is load bearing structure. And next is frame structure. So basically in the frame structure it is consisting of columns, this vertical columns and these horizontal beams. So whatever load of this slab, that will come to this beam and that will transfer to this column and then ultimately it will be transferred to the beam. So here all these walls, they are not responsible for taking the load. जहाँ पे ये load bearing structure में these walls are responsible for taking load. So these are the elements which are called as structural elements of building. So that should be properly secured so that it can be prepared disaster proof. Now next is non structural elements. So building में बहुत सारे non structural elements भी होते हैं. So basically the items of the building such as contents of building, appendages of the building, services and utilities which are supported by structural elements and whose weight and other forces are carried down by the foundations and which is called as non-structural elements. Okay, so basically this non-structural system that are generally also important, because if whenever there is an earthquake shaking and if these non-structural elements they are not secured through the structural elements properly, structural elements के साथ properly वो connected नहीं है, so it may topple down, it may slide down, it may fall down. Okay, also it may move or swing by the large amounts in the translation and rotation. Through this action that may cause loss of the item as well as it may cause the secondary disaster. For example, some laboratory or industrial unit, some spill of chemicals that may result in fire, toppling of the unreinforced masonry parapet wall और चिमनी, अगर आपके घर में चिमनी है, अगर उससे कुछ गिर जाता है, so that may injure other persons also. So these are all non-structural elements, but they are also to be secured properly so that it may not result in secondary disaster. So basically these non-structural elements that can be listed under three groups. Contents of building. So contents of building में all these furniture, minor items, that storage, cells, etc. Then facilities and equipment, all your furnitures, then refrigerator, washing machine, gas cylinder, TV, all are included in facilities and equipment. Doors and window panels, तो frames है, large glass panel, pans लगाए गए हैं frames में. So these are all responsible for giving certain amount of loads and that are to be properly secured. Otherwise, whenever some earthquake is there, so that shaking up of all these elements that may also result in secondary disaster. So they should be also properly secured. That is the thing. And appendages to buildings means attach किया गया building के साथ. So these items projecting out of the building either horizontally or vertically. Vertically या horizontally आपके building से वो बाहर निकल रहे हैं. Such as chimneys projecting out from your building. So if during some earthquake, if it is collapsed or if it is falling down, then that can result in secondary disaster. कोई नीचे है इंसान तो उसको problem हो सकता है. Glass or stone cladding used as facades and parapet wall, and small water tank. So if they are not properly secured, that may also fall down. Then sunshades, advertisement hoardings, and that are fixed sometimes in some buildings. Some small communication antennas mounted at your building. So these may also result in secondary disaster. So this is nothing but these are the stone cladding. So अगर properly secured नहीं है at the time of earthquake shaking, that may also fall down. Also this kind of this communication towers that may not be considered in the design. अगर किसी के घर के ऊपर लगाया है and if this building it is not designed to that take that particular load, Then when there is some heavy wind movement during a cyclone, or some heavy shaking during the earthquake, that can also fall down, and that may also result in secondary disaster. Similarly, all these holdings, etc., if they are not properly secured and not properly attached, then that can also result in secondary disaster. So these are all very important thing that you have to consider, that they should be properly secured. All the services and utilities of the building, they are also very important part, and they should be properly secured. All these water supply main, electric cable, gas pipeline, sewage pipeline, telecommunication wires, then air conditioning ducts, rainwater pipeline, then elevator, fire hydrant system. So you can say that all the structural elements and non-structural elements all should be properly secured against your particular hazard of earthquake. So this multi-hazard resilience and safety of both structural and non-structural elements, it should be given proper priority, and that are given concern in this guideline. And it is estimated that total cost of construction of building, the structural element का cost तो 25 to 50% होता है, but remaining is non-structural elements 50 to 75%. So there is a need to recognize the critical role of these non-structural elements also in the financial exposure in the building. And in non-building system, normally the share of non-structural elements, ये सब बिल्डिंग फिनिशेस एक्सेट्रा, वो सब दूसरे नॉन बिल्डिंग जैसे होते हैं इंडस्ट्रीज या इंफ्रास्ट्रक्चर प्रोजेक्ट, सिविक कम्युनिटीज, उसमें नॉन स्ट्रक्चरल एलिमेंट्स आर वेरी लेस. So generally this cost of equipment and facility which are generally used in building, which is more than the non-building type of system. So hence the safety and the multi-hazard resilience of non-structural elements, including equipments and facilities, from the adverse impact of natural hazard is a very serious issue, and it is to be similar to your structural elements. So you have to give concern to both the elements of your particular building, either it is a structural or it may be non-structural element of your building. And by doing such, you can make your particular building disaster proof. So in the next part we will be focusing on other part of your structural and non-structural mitigation. So thank you very much.